Okay guys, welcome back to my YouTube channel again. This is your Sadiq Santos Capellan. You can say also Santos Abe or Santos Bay, okay? Guys, what I'm going to do is to try to simplify my control logic program for this system, okay? Now the problem is when you are developing your logic, sometimes your logic becomes more complicated or complex because of the combination of logical gates. Okay, like this one I have here, this NOT gate, then two AND gate here, like this one. Now, guys, in this part 7, okay, so this will be our part 7. I'm going to introduce you to a new blocks, okay, that we can use to simplify this combination of uh, logic gates. Okay, now actually you cannot go away with the logic gate, but you can minimize the use of this logic gate, okay, by using the expression block. Now let me first, what I'm going to do is file, then I will save as. Okay, so I will keep this original control logic, then I will try to save it to okay, so this one EF stop, then I will say E, okay, expression block, okay, just to okay, so EF1 save. File name is too long. Okay, we are not allowed to use a very long. Okay, so EF, so EF. Okay, so I will say SF EF X black. Okay, now save. I hope that file name is okay. Okay, that's okay. Now what I will do, okay, like this one, I want to remove these two AND gates, then this NOT gate. Okay, so fire alarm. Okay, then okay, so what we can do, so how can I replace this with expression block? So let me just try to delete it. Okay, then this one also, I'll try to delete this one. Okay, now okay, I will try to use an expression block here. Expression. Okay, now this is the expression block. Okay, now first let me show you the help. Okay, so this is the block. So expression block binary output, expression block integer output, then expression block real output. So we have XPB, XPI, and XPR. The expression block is a special block with one parameter, an arithmetic expression, okay, which may be simple or complex. It can be simple or complex. Depending on the expression, the block can have few or many inputs. Okay, so your expression can have several inputs. Okay, the graphic representation, the block may change in size. Okay, of course, if you have so many inputs, the expression block will change in size. Now, dependent on the expression size and or the number of inputs, okay, there is only one output signal for the expression block. So meaning there is only one output, okay, dependent on the output signal type, real, integer, binary. Okay, so let's see. Now I want to use expression block binary. Okay, so binary output. So operands, the operands of the expression may be these are declared in the expression by a single letter, which is capitalized ABC, represents an analog input. So if we are going to capitalize your input with capital letters, meaning it will represent an analog input. So meaning your input is analog, okay? While if in lowercase ABC, the variable is a binary input, okay? So we are going to use lower letter ABC, okay? Okay, so let's just focus on this. So since we are going to use XPB, binary output, so we are going to use lowercase inputs, ABC, and so on. Okay. Now, numeric constant. The constant is an integer portion, which may be preceded, okay, integer portion, which may be preceded by plus or minus. The integer portion may be followed by a decimal point and the decimal portion. Finally, an exponential portion. Okay. Now, let us just focus with these inputs. Okay. So let me use now. So I'm going to use XPB. Okay. Now, actually, what I have removed there is two AND gates and one NOT gate. Okay. So first, we can say A. Okay. So I can say that now I'm going to develop the expression here. A. Okay. A and B and B. So that will be equivalent of the first AND gate that I remove. Okay. And B and C. Okay. I already have here four inputs which are being representing the two AND gates. Okay. And I think I will say and let me just see if this is correct. Okay. And okay, where is that one? And not A, B. No, no, no. This one will be C, D, E. So A and B will be my first AND gate there. Then C and D will be the next, the second AND gate that I remove. Then this is the NAND gate. Okay. So okay. Now it was saying that the gate or the expression block will grow in size depending on the number of inputs. Okay. So just let's give. Okay. So maybe I will delete this note. Okay. Then I will try to. Okay. So let me move it here. So this is for our. Okay. That is for our alarm generation for fire alarm. So I will put it here. Okay. Okay, then I'm just trying to make the what you call this one. I'm just trying to make the logic more clearer. Okay, so now actually now it's time to connect all these inputs to our expression block. First, the operator enable. Okay, so I will try to create a node here so that this will be my first input for my expression block. Now, again, it is not necessary to identify the expression block, okay? So, if it is operator enable is true, then this one, I will use this one. And EF1 how to status is true, okay? Then what else? EF13, okay, I think and not, I think I need to because we are going to use this strip. And then what else? What other information that we're going to use here? Okay, so let me just check this genset here. I'm using it here. Okay, I'm using it here. Then I'm using also here. Okay, no problem. Okay, now since I'm going to use this, I'm going to use this one. Okay, no issue. But what is the other input that I need to use here? Okay, so okay, guys, let me start also my so that I will be able to see what are the inputs. That one. Okay, I will open also this. Okay, So I'm trying to open the original function block. Okay. Wait. Is this the one? No, this is not the one. Just a minute. I'm trying to open my, see, this is not the one. Okay. Okay. So let me just work it out. Okay. So, okay. So what else? Okay. If time schedule and hand up auto status and not trip, okay, and not fire alarm. Okay, so I have two inputs here and gen set. Okay, now I can say, okay, now I will change this one and not E and not D. Okay, because I'm going to use two negation there. Okay. Okay. So, CD. Then what other information are using? Now, this is the problem, guys. If you are going to uh, try to redo the control, it is much better if you are going to uh, do it from the very beginning or from the scratch. Okay, but anyway, let's just try to see how can I. Okay, so I will try to remove that one. Okay, so A and B and not C. Okay, so I will remove this. I will remove this other. Okay, so if A and B and not D and not E. Okay, now the expression block is shrinking. Okay, so I'm going to create a node here. Okay, okay. So okay, then of course I'm going to create this strip. So I'll try to create a node here. This strip. Okay. Then I'm going to create a node here. Okay. So this expression block, meaning if it is in auto and it is in, no, if it is operator enable, okay. So then if it is in auto and not fire alarm and not trip, okay, then I can use this logic. Okay. So I can use this one here. The output, I will feed it here. Okay. Likewise, the output, I will feed it here. Then maybe we can check if still it will run. Okay. So do I need to connect some disconnected inputs here? Okay, so let me just save it. Save preference. Okay. Now option simulate. Okay. So meaning there is no problem there. Okay. So let's see if our logic is still correct. So just to wrap it up, I try to remove some of the logic gates and try to simplify it using this first expression block that I'm trying to explain to you. Now I'm using here an expression block binary. So just to give you the rules in using expression block binary, you have to specify that your inputs will be in lowercase. So A, B, C. Okay, now I think there is a problem here. Okay, let me go to options, edit. Okay, now I just want to make it correct. A, B, C. Okay, so I will say here C, then D. So I just want to use alphabetical inputs. Okay. So anyway, so okay, let me delete this, then redraw the. So okay, again I will redo here. Okay. Okay, then fire. I will create it here. Create a node here. Okay, now if it is operator enable and hand of auto status and not fire alarm and not trip, then use it again here. Okay, now we will see this one. I think this one is not okay. So anyway, I will try to remove this. Okay, I will try to remove this later, but I want to check first if this expression block did not create any problem in our uh, control logic. But I think this AND gate is redundant. But anyway, let's just first simulate it. Okay, now let's execute. Okay, so as you can see here, as you can see, first let me this one. Let me put it the operator enable. Okay, I will say okay the operator enable the system. Okay, so I have one here. Okay, now the expression block still the output is 0. Then we need to put it in automatic. Okay, as you can see now the output of my uh, expression block is already 1. Okay, then I need to turn on the generator set for the, let's say the generator runs. Okay, so 1. So what happened here? Okay, so let's see. Okay, then the damper are not being commanded. Why? What is the reason there? Genset is running. Okay. Okay, let me go to the okay. So first let's see what is happening here. Because we need to give the command to the damper before the punch will start. So what is happening? So I have here already a 1, okay, but here I have a 0. I have a 0 here. Okay, now we need to make also the SF supply pan automatic. Okay, now I'm giving, so meaning our system both the supply both the fans SF and EF should be in automatic before our based on the logic before we can give the command to the damper, because we don't want to open the we don't want to start the fan if the damper are closed. Okay, okay, now since our logic already started or gave or give the open command to our dampers, then what we expect after several after maybe 1 minute, then we should receive we should be receiving the SF damper open status, then EF damper open. Okay, as you can see here, let me see. Now, when we receive the uh, open status for both dampers, then our start stop command for EF1 and SF here is on. Okay, so meaning the inserted expression block did not make any conflict with the existing logic. Okay, now here let me check this one. Okay, so this AND gate. Okay, now still we can simplify the control like this one. Maybe we can use one expression block for this combination of several logic gates. Okay, now what else? Okay, now maybe this one I will try also to remove this. Okay, so EF13, EF13, then where is the SF3? So I'm using this one also here. Okay, so guys, we will try to simplify these two. So we will remove this. Again, we will remove these two NOT gate and these two AND gate. Okay, so maybe that will be the coverage of this part. This is part 7. Okay, so let me edit the. Okay, so again, I'm going to use the same expression here. So meaning I can copy that one. Okay, so I can remove this two AND gate here. so that we can simplify. Okay, so let me remove this one, then let me remove this also. Okay, anyway, so this end gate here, I will remove that one. Okay, okay, now, okay, so I cannot I don't need to remove this because it's connected there. Then later maybe we can try to remove it also. Okay, so I'm going to copy this. Okay, because I'm going to use the same expression block. Okay, Control C, Control B. Okay, here you go. Okay, so let's put it here. Okay. Now guys, sometimes when you are copying, then this small square will appear. Okay, so you can just remove it, no problem. So again, if genset, okay, so I think this is part of the, okay, so let me create a node here. Okay, create a node. Okay, and not fire alarm. Okay, I think I'm going to use, okay, no issue. And it is in automatic. And it is in automatic. Then where is the trip? And not trip. Okay, I will create here. I will create here, create node. Okay. And of course, fire alarm. Okay, so I'm going to create a node here. Okay, create a node here. Create a node because fire alarm, we need fire alarm signal. Okay, so if it genset is running and it is in automatic, the supply fan is in automatic, and there is no trip and there is no fire. Okay, then the output of this will be 1. So I'm going to feed it here. Then of course use the same uh, output for the input of this. Okay, now I think, let me see. Okay, let's save it. Save. Okay, then let's go to our option simulate. Okay, there's no problem. So meaning we were able to remove successfully the logics. Okay, I mean the logic gates. We are able to remove it. Then it did not affect our logic. Okay, now later in part 8 we will try to remove this combination of several. So the coverage of this tutorial part 7 is just to introduce to you to an expression block wherein you can use it to simplify your growing or your becoming complex logic. Okay, so maybe in part 8 we will try to remove again some of the combination of logic gate so that we can simplify our this one also. We will remove it in part 8. Okay, so guys, this will be the coverage, and I hope you already have an idea how are you going to use expression block binary output. Okay, so XPB. Then later, as I said, we will be doing more uh, tutorial in relation to function block programming. Okay, so guys, thank you again for joining me in this part. And if you are new to my channel, needless to say, support, uh, likes, share, and comment. And once again, I would like to stress that I am not an expert. I'm just trying to help beginners in this kind of field. Okay, so this is your Sadiq Santos Abe, and by saying God bless us all, let's all be safe, and bye for now.